Hi, hello everybody. So this is the video dealing with section 4.3, right angle trigonometry. And for this topic, I've divided the section into two videos. The first one is going to be our definitions of the right triangle of these trigonometric functions. And the second one, we'll talk about the applications. Now, the main definition is, as you see here, we have a triangle. This is a generic right triangle. So a right triangle is a triangle that has one angle being 90 degrees. So this is a 90-degree angle. And then this angle theta and this other angle theta are the other two angles. Now on the right triangle, we obtain these functions. These are the trigonometric functions of the angle. The main ones are these three: sine, cosine, and tangent. This is one definition on the circle. Sine is one definition on the circle. This is another definition. Tangent is the ratio of sine and cosine. And these other three, cosecant, secant, and cotangent, are all inverses of sine, cosine, and tangent. Okay? Now, I wanted to show you exactly what these functions look like on the actual circle. So I have here an app, which is not mine, but it's the trigonometric functions on the unit circle. And let's see if we just show you real quick what they look like. So here is the unit circle, and as I move, right? So I'm moving this black line. As I'm moving the black line, you can see the angle formed here by this light blue. So the angle formed with the horizontal or the x-axis. Now, the value of sine is the red line. The value of cosine is the blue line. So as you can see, as I increase the angle, the value of sine increases, the value of cosine decreases. And it gets to a point where all of the value here at 90 degree is sine equals to 1, because this is a unit circle meaning a unit of 1, and cosine is 0. As I increase the angle some more, going to 180 degrees, the red line is the sine, so it decreases and cosine increases. And it increases until I am exactly at 180 degrees, and cosine is -1 or -1, and sine is 0. And it continues again, going around and around. So this is sine and cosine, okay? The two main functions. Tangent is sine over cosine, and the other three are just their inverses. Okay, so this is maybe somewhat important for you to know where they came from. Now, in algebraic terms, let's just take a look real quick. In algebraic terms, we'll take a look at these three first. The other three are just the reciprocals. Sine of this angle, so once you have a right triangle, right, a triangle that has 90 degrees, the sine of this angle is the opposite side of the triangle in relation to theta divided by the hypotenuse. So that is sine, right? Opposite. So we normally say opposite divided by hypotenuse. For cosine of this angle, adjacent side divided by hypotenuse. Okay? So adjacent by hypotenuse. And tangent is, sine over cosine, or, on the triangle, if we go on the triangle directly, so tangent of this angle is opposite side over adjacent. So opposite over adjacent. And then the other three, we have the same definitions on the triangle, but it's just easier to do the reciprocal. So sine of theta is opposite over hypotenuse. Cosecant will be hypotenuse over opposite. Cosine is the reciprocal of secant. So if cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. And then tangent, opposite over adjacent. Cotangent is adjacent over opposite. And again, when we say adjacent and opposite, we mean adjacent side to the angle theta and opposite side to the angle theta. Now, obviously, you might be thinking, well, how about the other angle right here? Well, we can do this on this angle also. Call it theta 1. But now, in relation to theta 1, A would be the adjacent side, and B would be the opposite side. Okay? So in case you wanted to do it that way. Okay, so now let's take a look at these are the only questions that we are going to ask you related to these right trigonometric functions. We'll give you a triangle. In this case, in both cases, we have to give you two values. We'll give you two values. And they could be the sides, right? So let's say that this is theta. Or we could give you we can give you the hypotenuse and just one of the other two sides. It doesn't really matter which way we give you. You can always find the missing side by the Pythagorean theorem. Okay, so you remember the Pythagorean theorem is c squared, meaning hypotenuse, a squared plus b squared. So in the case of the first triangle here, example 1, how do we find? We have to find c, right? Our goal is to find all of the trigonometric functions. So sine, cosine, tangent, cosecant, secant, and cotangent. All right. Before we do that, I have to find c. We have to find all the sides. Okay, so let's find c first. So c squared is 12 squared plus 5 squared. This is 144 plus 25, 169. Now I have c squared equals 169, so I take the square root of both sides, and we get that c is 13. Okay, so now I have a new triangle, or a complete triangle, where c is 13. Now I can find the value of all 6 trigonometric functions. It's extremely easy. So notice I don't know what the angle is. Later, we'll learn, in a different section, we'll learn how to find this angle. But for now, I just need to find the sine of the angle, the cosine of the angle, and so on and so forth. So once I know all of the values, right, I apply the definition of sine. Now, what is the definition of sine? The definition of sine of this angle here is the opposite side over the hypotenuse. And that's it. I'm done. That's all I have to do. Let's find the cosine. Cosine is adjacent side over hypotenuse. Right? And I know sometimes it can be a little difficult to remember or memorize these things. So let me pull them up. So let's take a look again. It's easy to forget. So normally, we have students memorize these functions. We only have to memorize sine and cosine, and then we memorize that tangent is the ratio of sine and cosine, and these are the three are their reciprocals. So we only usually have to memorize these two. Okay? So again, look at sine, right? Opposite over hypotenuse. Cosine adjacent over hypotenuse, right? Tangent theta opposite over adjacent. Okay. And cosecant is the reciprocal of sine. So if sine is 5 over 13, cosecant is 13 over 5. Secant is the reciprocal of cosine. So if cosine is 12 over 13, cosecant 13 over 12. And then cotangent of theta is the reciprocal of tangent. So if tangent is 5 over 12, cotangent is 12 over 5. That's all we have to do in this section. Okay? Now the same would apply here for the other triangle. But in this case now, you are given the hypotenuse and one of the sides, and then you have to find the other one. So we applied the Pythagorean theorem the same way, right? But now you have C. So 3 square, 1 square plus B square. So 3 square, 9, obviously 1 square, 1 plus B square. So subtract 1 from both sides, and I have this. So take the square root of both sides again, and I have B being the square root of 8. So normally we have to simplify this radical, right? So 8 is 4 times 2, which is radical 4 times radical 2. Radical 4 is 2. So square root of 8, we normally write as 2 radical 2. Okay? I am going to leave it as radical 8 here for simplicity. But if this is a question on an exam, we would write this format. Okay? But since I'm only trying to find the trig functions, we can use radical 8. It's perfectly okay. All right, so now find the functions of theta. So here's the angle theta, and just as before, this is the opposite side to theta, B is the adjacent side to theta, and C is the hypotenuse. So sine, opposite over hypotenuse. Cosine theta, adjacent, you can write radical 8 or 2 square root of 2. Adjacent over hypotenuse. Tangent theta, opposite over adjacent. Now, in this particular case, we cannot leave a radical in the denominator, so you multiply by radical 2, radical 2. So in the numerator, I have radical 2 over radical 2 times radical 2 is 2, times the 2 is 4. So we can't leave the denominator in irrational format. So you have to rationalize. And then cosecant theta is the reciprocal of sine. So 3 over 1 or just 3. Secant is the reciprocal of cosine. So flip the values. All right, so 3 over 2 radical 2, and then I have to rationalize it again. So 3 radical 2, this is 2 times 2, 4. And cotangent theta is the reciprocal of tangent. So 4 over radical 2. And then I'm going to rationalize. So this is 4 radical 2 over 2. And then I simplify the 4 with the 2. So cotangent theta, 2 radical 2. Okay? So all we have to do is find the missing side and apply the definitions of the trig functions on the triangle and find those 6 values. Now, these are angles that we do not know. Now, what does that mean? It means that there are some angles that we must know because we, on exams or final exam, will ask for the exact value of a particular function. So the angles are 0, 30, 45, and 60 degrees. 90 degrees, we have to know the values of sine, cosine, and tangent. We really need to know only sine and cosine because tangent, we just divide sine by cosine. Okay, and the same thing goes for cosecant, secant, and cotangent. So the only values that we really need to know are right here. Okay, now we normally tell students to memorize these, but I am going to show you here how they are derived. Okay, so that you know, not that you need to know this or should know this, my recommendation is just for you to memorize it. For the 45, right, they're derived the following way. So you start with the square. So here's a square, right? So on a square, I have 90 degrees all around, and then I draw a diagonal right here. When I do this diagonal here, this angle here is half of the 90 degrees, which is 45. This is my theta. If this square has a length of 1, then this side is 1, this side is 1, and this is my hypotenuse. So I'm going to find the hypotenuse now. So 1 square plus 1 square is just 2, and then take the square root of both sides, and I get my hypotenuse square root of 2. Now I find the trigonometric functions. So let's just do 3, okay? Sine, cosine, and then tangent of 45. Okay, so the values are up here. So here's 45. All right, so sine of 45 is opposite over tangent. But I can't leave this thing here, so I have to rationalize. So that would be radical 2 over 2. So sine of 45, radical 2 over 2. Same thing for cosine, right? Adjacent over hypotenuse. And it's the same thing as sine, so this would be radical 2 over 2. The same thing. And let's do tangent of 45. Tangent of 45 is this sine over cosine, right? So obviously radical 2 over 2 over radical 2 over 2, obviously it's 1. So there you have it. And then you can find the other 3 trigonometric functions using the reciprocal identity. Now, what if I wanted to do the 30 or 60 degrees? So let me show you how that's done. Okay, so imagine you have a triangle such that all of the internal angles are equal. Now, you remember this from another class that if that happens, right? If the sum of all the internal angles of a triangle equals to 180, and if I have three identical angles, each one has to be exactly 60. So now I slice this angle here in half. So this becomes half of 60, which is 30. All right, so now I have this angle being 30, this angle being 60, which means that this angle is obviously 90. This is now my angle theta. So I'm going to flip the triangle this way for you to see. Here is my 30 degree. Here's my 90 degree, and here's the 60. So this is the triangle that is going to help us find the functions of the 30 degree and 60. I'm only going to do the 30 for you to see because 60 is the same thing. So sine of 30, cosine of 30, and tangent of 30 degrees. Okay, so these values we have to know, the 0, 30, 60, and 45. The 0 and 90, you can do it on the calculator or from the unit circle. Okay. But so let's imagine now this triangle has, again, side 1 or side 2 to make it easy because we're going to split it in two. So this is 2, this is 2, and this thing is 2, which means that this side is 1. Okay, so the hypotenuse of the triangle here is 2, and the opposite side, this side right here in relation to theta, is 1. And I need to find this length here, which is my height right here. So we use the Pythagorean theorem again. So c squared, a squared plus b squared. In this case, c is 2, so I have 2 squared, 4. A squared is just 1, and then b squared is just b. So I have 4 equals 1 plus b squared, so I'm going to subtract 1 from both sides. I get 3 equals b squared. Take the square root of both sides, and I get square root of 3. So this value right here is the square root of 3. So now I'm going to do sine of 30, which is opposite over hypotenuse. So 1/2. So sine of 30, 1/2. I'm going to do cosine, not it looks like cosecant, but it's cosine. Cosine of theta, which means cosine of 30. So cosine is adjacent over hypotenuse. Right? So cosine of 30. And then tangent of 30, which is sine over cosine. So sine over cosine. So you remember how to divide fractions. You multiply by the reciprocal, right? So these two cancel, and I have 1 over radical 3, but we can't leave the radical in the denominator, so you must rationalize. Multiply by radical 3 over radical 3. So this is the rationalization part is from Math 119. You should remember that. If you don't, just watch a video for like a couple minutes, you remember. So radical 3 times radical 3 is radical 9, which is 3. So here's tangent of 30. Okay? Now, the same thing can be done if I now say that this is my angle theta. As we said before, if that's the case, then the 1 here would be the adjacent side, and then the radical 3 would be the opposite. And we can find the same values. Now, you don't have to do this derivation every time you need to find these values, okay? The best way to do them, to do these problems is to memorize these values right here. So we need to know these 9 because they may come up where you have to find the exact value of either 30, 45, or 60 for sine, cosine, or tangent. Tangent, you don't really need it because you can divide sine by cosine. So it's really only these 4 that we have to memorize. Okay? So make it a habit to do that because future problems will require this.